All right, the second half of Unit 3. Today we're going to start talking about the properties of quadrilaterals. Okay, now there are quadrilaterals just a four-sided shape, nothing big of that. However, there are specific shapes within the quadrilateral family that do have some properties that are very, very specific to their shape. So here we go. We're going to start off with parallelograms. There's 5 different properties that go along with all parallelograms, and they are this. Opposite sides of the parallelogram are parallel. So what does that mean? This side up here is going to be parallel to that side down there. And also, this side here is parallel to this side here. The second thing that we have is that the lengths of opposite sides are congruent. So this length here and this length right here, those two sides are the same length. And this side here and this side here, they're the same length as well. The other thing that we know that opposite angles are equal. So the angle that lives here and the angle that lives there are the same. This angle here and this angle here, they are the same. Consecutive angles are supplementary. In other words, if I take two angles that are next to each other like this one, let's call this angle A and let's call this angle B. If you add angle A plus angle B, so angle A plus angle B, you're going to get 180 degrees, okay? If you take angle B, and what we have down here is angle C, so angle B plus angle C, because they're consecutive, one after the other, those two will also equal 180. I hope you get the idea. I go down over here to D, okay? Angle C plus angle D, those two guys together are going to be 180. And then in the end, angle D plus angle A, those two guys equal 180 as well. Okay. The last thing that we know is that the diagonals of my parallelogram, they bisect each other. So what's a diagonal? A diagonal basically is the line that connects opposite vertices. So here's a diagonal. Okay. And here's the other diagonal, right? They shoot diagonally across the parallelogram. What we know about those two is that they bisect each other, meaning this length from here to there is the same as the length from there to there, okay? And also the length from here to there is the same as the length from there to there, okay? So we've got those 5 properties. I've got some examples that are coming up right here, and we're going to keep these 5 properties handy next to us the entire time as we go through this, okay? So let's take a look at our first set of problems, our first example. Okay, we need to find the value of the missing variables. Here's what we know. Let's start off with the 50, okay? To me, it just seems the easiest. 50 right here. What do I know about this angle and this angle? Hopefully we go to this one. Opposite angles are equal. So that means that the measure of angle C is 50 degrees. When you have a sheet of paper, it's a good idea to fill in this information on the actual drawing. Okay, don't try to write things over on the side. Fill in the information that you know. Here's the other thing. Let's find out the measurement of angle A and the measurement of angle B. What do we know about this angle plus this angle? Hopefully we know that consecutive angles are supplementary. So 180 minus 50 right here leaves me with 130, and then we go back to this. Opposite angles are the same, so that's 130. So far, no, we haven't had to do hardly any algebra at all. What do we know about angle 5, or excuse me, not angle 5, but the length of this side up here is 5, and the length of this side right here, hopefully we know this. Opposite sides are equal, so the measurement of this length should be 5, and the same thing goes with this. 3 and this side, they better be the same as well. So there we go. We filled in all of our missing variables with just those simple steps, just applying what we know about the properties. Next one that we have right here, fill in what we know. The measurement from A to D is 5x plus 3. And the measurement from B to C, and guys, by the way, C belongs right there. The distance from B to C goes 7x minus 9. Now, how are we going to find out the value of x? Let's go to this one right here. Opposite sides are equal. So if we know that this one is equal to this one, write it like I just said it. 5x plus 3 is equal to 7x minus 9. Now we've got some algebra to do. We've got to balance this equation. So subtract 5x from both sides. Now I'm going to add 9 to both sides. And the last step always, got to divide. So here's what we find out. The value of x is equal to 6. Now, how far apart is A and D? Now let's take that value that is 6 right here. X is 6. And we're going to plug it back in here to the AD statement that we have, or the relationship that we have. So it becomes 5 times 6 plus 3. So we find out that the distance from A to D is actually 33. And 33 what? In this case, it's just units because nothing's expressed to us. So again, using algebra to apply to the properties that exist for a parallelogram. A little different here. Now we're not talking about side lengths anymore. Now we're talking about angle measures. So again, I say fill in the information that you know where it belongs. So the measurement of angle B is actually 3x plus 5. And that measurement belongs right there. And the measurement of angle D is 8x minus 45. And that measurement belongs right there. So we're actually asked to find out what is this measurement right here. However, in order to do that, I need to know what this value is or what that value is. So what do we know about this angle here and this angle over here? Well, hopefully we know this, that opposite angles are equal. So set that up the way that we see it. 3x plus 5 is equal to 8x minus 45. And again, go through the process of balancing the equation. So we find that the value of x is 10. So what do we get when we actually plug in the value of 10 back into one of these? Well, here's what we know. What's 3 times 10? I get 30. What's 30 plus 5? 35. So the measurement of angle B is actually 35 degrees. Now what do we know? Now we need to go to this. Consecutive angles are supplementary. So in order to find the measure of angle C, I need to do this. 180 minus 35. And we find out that 145 degrees is what is left. So that means that the measurement of angle C is actually 145 degrees. Now, does that make sense? Is 145 plus 35, does that equal 180? The answer is yes, so we're in good shape right there. So we're looking at this, and now we have basically the same idea. I've got some angles right here. However, the structure of this one's very, very different. So what we need to do is, again, write the information where you see it. So angle D belongs over here, 7x plus 10. That lives right there, okay? Now the information we have is for angle C. So that one's actually 3x plus 90, okay? Now these angles are not opposite, right? They're right next to each other. They're consecutive. What do we know about consecutive angles? They're supplementary. Okay, so when we have two angles that are supplementary, we need to add them together. So here's what we got. Let's go to 7x plus 10 plus 3x plus 90. Now remember, when I add this angle here plus that angle here, what should they equal? Supplementary angles are always equal to 180. Okay, now my variables are on the same side, so we need to combine like terms. So here we go. I got a 10x plus 100 equals 180. How do I get that? 7x plus 3x is 10x. 10 plus 90 is 100. Do the process of balancing the equation now. Subtract away 100. So we've got 10x is equal to 80. And now the last step, divide by 10. And x is equal to 8. However, the question here is not find the value of x. The question here is telling us I need to find the measurement of angle A. Well, where does angle A exist? Check it out. Angle A is way over here, isn't it? Well, angle A is exactly the same as angle C. How do I know that? Because opposite angles are congruent. So let's take this value. I've got the value of 8 for x, and I'm going to plug it into the equation that I have here, or the expression that I have for angle C. So it looks like this: 3 times 8 plus 90. So I've got 24 plus 90. So we find out that the measure of angle A is actually 114 degrees. All right, guys, last one for you, I promise, right here, but this is kind of the last of the 5 properties that we have not done any algebra with, so we need to work on some diagonals here. What do we know about diagonals? Here's what we know. The diagonals bisect each other. So the distance from D to E is the same as the distance from E to B. Also, the distance from A to E is the same as the distance from E to C. That's what bisect means, cuts it directly in half. Now let's look at the information that we actually have. DE is 3x plus 4. Fill it in. So I got a 3x plus 4. There's the length from D to E. BE is 5x minus 10. That guy lives here. 5x minus 10. There's BE right here. I know I'm doing it backwards. It's okay, though. So BE is 5x minus 10. So what do we know about those two guys? That mark right there and that mark right there indicate that the two line segments are exactly the same. Another way to say the same, equal. So 3x plus 4 is equal to 5x minus 10. Okay? Again, variables on both sides, get them together. Now I need to isolate it. And the last step is always divide. So in this case, the value of x is 7. Okay? However, we're trying to figure out what is the length of BD. If it's me, I'm going to take this information that is 7 right here, and I'm going to plug it into one of these two. Okay? Seems to me that this one right here will probably be the easiest. And again, that doesn't make any difference. What do I know about this? I know that whatever the length of EB is, if I double it, then I've got the length from B to D. So let's figure out what BE is first. Take that information. I've got 5. I know the value of x is 7. And then I subtract 10. So 35 minus 10 is 25. So the length from B to E right here is 25. 25 what? Just 25 units, okay, because nothing's named. So that means if I take the 25 and double it, now I've got the distance from B to E. So double 25 is 50. It's an ugly 5. So there's where we finish up. Okay, this lesson was pretty long, I know, but we've got to get some foundation for the properties of parallelograms. Hopefully all the other properties that we have for our other quadrilaterals will go a lot quicker.